Hello everyone, welcome back to the channel. Today we are going to understand one of the elastic load balancer of AWS, which is network load balancer. We have already covered application load balancer in the other video. Now we'll look understand the network load balancer. So network load balancer basically it operates at layer 4, which is basically for ultra high performance. Okay. So when you need very ultra high performance, high throughput, and also static IP, right? If you need static IP, we'll come to that. What is that static IP? You can use it for whitelisting. In that case, you can opt for network load balancer. It operates at layer 4. When we say layer 4, it's basically it is not able to read the header URL etc. and pass it on to the client. It will just pass the client IP, destination IP, uh, the client port, and the destination port. That's it. That's the only information it provides. It's like forward. It just makes the forward request to the target. That's it. And what are the various targets that you can have in the target group? It's basically EC2 instances, the IP addresses, ECS tasks, EKS pods, etc. You cannot call Lambda, right? Just keep that in mind. You can only call Lambda from application load balancer. Just keep that in mind. That's one of the difference in the target group of the application load balancer and the network load balancer. And the various ports that are supported, it's like 84, 43, 3306. Okay. Now moving on to the next part. Uh, So it supports TCP, UDP, and TLS. Okay, when we say TLS, it's basically the Transport Layer Security SSL certificate, secure in transit, basically encryption in transit. So that's what it supports. It supports static IP. So we'll come to that. We'll cover that part, the static IP part. Okay, and it preserves client IP address. That's what I told. It will directly pass on the client IP address, destination port. Sorry, the client IP, the client IP port, etc. And it also supports health checks. It supports cross zone load balancing. It is not enabled by default actually in case of network load balancer, but you can enable it in the target group. Okay. Now it supports dual stack as well, so you can have both IPv4 and uh, IPv6. Okay, and it integrates with auto scaling, CloudWatch. I mean whatever you have in the uh, target groups, and it also integrates with AWS WAF. Okay, it is not ideally for it is ideal for non-HTTP workloads. It is not ideally for the HTTP workloads. For HTTP workloads, you always go for the application load balancer, as we have to process the header and all those stuff, right? So there you'll go with the application load balancer. As far as the network load balancer is concerned, the use cases would be like databases, Redis, Kafka, and all those kinds of services that you can target with the network load balancer. Now coming to the flow, basically client sends a request to NLB, NLB receives the connection, it evaluates the listener, and if the target is healthy, it will pass on to the selected target, basically any instance, etc., using the private IP, and then the response is sent back. And what it uses, basically, it uses the flow hash algorithm. So the flow hash algorithm is basically what I told you, right? At layer 4, it is just going to see source IP, source port, destination IP, destination port, and protocol. That's it. And based on this, so if it is receiving the same request, right, every time. So based if it is coming from the same client and the destination IP and destination port is the same, it will always send it to the same target most of the times. Okay, so it ensures that stickiness of session affinity, you could say, it is being provided using this slow hash algorithm. In what we spoke about the listener configuration, so you can forward it to various target groups. So these are the various ports that it can support. So for MySQL, like 3306 port number. Then for the UDP, you can have 119453 for TLS 443. So all those kinds of uh, port numbers and protocols are supported. And it also has this health checks, which is very important. So whatever number of instances that you have in the target group, okay, so it makes sure that it has the minimum number of instances up and running. And only then it will send it to that particular target group. Otherwise, it will not send it to that particular target group. And the target group actually gives that status of healthy and unhealthy. And based on that, the load balancer basically, be it NLB or ALB, it can decide which target group it can send it to or which instance target group should be healthy. So that's the idea. And coming to the static IP support, see what happens when you create the network load balancer. So say suppose I'm creating network load balancer, okay, with three AZs. Now with three AZs, what will happen? It will have one IP address for AZ1, one IP address for AZ2, and third IP address for AZ3. So these are the IP addresses. These would be static IPs. So you can even use elastic IP. So when you use elastic IP, basically your IP address won't change. So that's the advantage that you get with elastic IP, and it will be one per AZ. Okay, just keep that in mind. And you can easily do that whitelisting. Okay, you can easily do that whitelisting in your application. So that is one of the things which network load balancer provides, which is not there with the uh, application load balancer. Now with TLS SSL termination or TLS termination, it's basically client sends a request uh, with the TLS basically encryption in transit using the TLS certificate. It comes to the network load balancer. Now network load balancer has two options. It can directly forward the traffic, okay, uh, with as it is without decryption, and that is basically it is called as pass through. And when we say termination, termination is basically it will end the TLS or the secure socket layer connection here itself, and then it will just forward the TCP to targets. Basically non-secure uh, kind of request will be sent to the targets. So here it does not have that particular load of having that certificate of decrypting or sorry encrypting the sending the encrypted packet to the target. So here we are terminating the TLS or the SSL. As far as cross zone load balancing is concerned, it is disabled by default. It is not recommended for network load balancer, but it is recommended in application load balancer. So what happens as far as cross zone load balancing is concerned? Say I have 6 instances here, and if I enable the cross zone load balancing, so it will distribute the traffic evenly between the AZs. And if I don't do that without cross zone load balancing, it is possible. Let's say suppose I have 4 instances here, 2 instances here, and one instance here, right? So what will happen that AZ3, uh, it won't be evenly distributed. So that's the whole logic about the cross zone load balancing. As you can see that the traffic won't be evenly distributed. Say suppose what happens basically in these three AZs, 30%, 33%, 33%, 33%. So I have one instance or two instance here, and then it will be divided like 15%. Say suppose I have four instance here, then 33% would be divided into four, which is like 9%, 9%, 9%, 9%. So here it is 9%, here it is receiving 33%, right, of the request. So it is not evenly balanced. But in case of cross zone load balancing, what will happen? It will evenly distribute. Even though AZ1 has four instance, AZ3 has one instance, it does not matter. It will take cumulative of all the AZs, and then it will evenly distribute uh, in the terms of 100%. Okay, that is cross zone load balancing. You have to enable it. Uh, like I told you, it is used for very high performance or ultra low latency cases. So gaming servers can use it for Redis, databases, messaging systems like Kafka, IoT devices, and it has easy integrations with the auto scaling CloudWatch WAF. And this is the difference between the application load balancer and the NLB. Like it will do layer 4 and layer 7. These are the different protocol that they support. Okay, and it is routing is based on IP input, and here it is based on content. And in terms of performance, it is ultra high performance. Here it is very good performance, but not very high. I mean, still NLB outperforms ALB. Client IP preservation. Here it can preserve it, but via the headers. And then here there is static IP, and ALB has no static IP. It is dynamic IP. Health check protocols. Basically, it can support TCP, HTTP, HTTPS, TLS, etc. ALB can support HTTP and HTTPS use cases like we have spoken about. Now we'll just look at the hands-on or the in the AWS console how it looks like. So I will start with the VPC. I have already created this VPC, and you look at the resource map. I have two public subnets. In one is in 1A 1A availability zone, and other one is in 1B availability zone. Both of them are routed or associated to public route table, and this public route table is connected to internet gateway. And this internet gateway allows internet access. Basically, that is why it's a public subnet. So this is the configuration of VPC. Now let's go to EC2. In case of EC2, I have my these two instances. So one is admin instance and shop instance. Okay, so this is my first instance. So this has my application. these both the instances, and we just want to check what is the output. It is running on 8080, and this is the path. As you can see, we get this kind of output. If I use shop, we get the shop controller. If I use the other instance, we have the shop controller. Okay. So now we get this output. We can see the, and now we have to create the target groups. First, once you have launched the instances, you can create the target group. Here I have created the two target groups, and how to create a target group. When you click on the create target group, you get all these four options. We'll go with instances for now. And in the instances, we just give the name to the target group. What would be my protocol? So in case of network load balancer, right, we have to use the uh, network load balancer for TCP and TLS. Okay, when if it is secure connection, and if it is HTTPS or ALB, this clearly mentioned here. So this is your protocol type. And in our case, since the application is listing on port 8080, so I'll just keep it as port 8080. Okay, and then we have to select the VPC. Then you can provide details of the health checks, like what is my health check URL, and so based on that, your health checks will be done, and that is it. And after that, once you do that, you can register the instance which is going to be used in your target group. So in our case, for this admin group, we are having this admin instance, okay, registered with this one. And in health check, you can see this is the URL path that we have set. Once this is set, you are already as far as the target group is concerned. Now there are few more attributes that we need to. Actually, I just wanted to go through that. Uh, this is your unhealthy target connection termination rate. Indicates how existing connections are handled before target becomes unhealthy. So basically, say suppose my instance is unhealthy, right? So if so how do I terminate the connections? Right? Say suppose some of the requests are still getting processed, right? So how do we terminate? Should it terminate the connection, or it should maintain the connection, right? And then if we are maintaining the connection, then we mention the draining interval. So like how much time should we wait till the processes will be completed? So the grace period, kind of, it's a grace period. Say suppose I send a request, okay, and request goes to a particular instance, and my that particular process actually takes a 100 seconds. Okay, so I'm just putting a very big number. So it won't be 100 seconds, but say 30 seconds. It takes 30 seconds. Generally, my process takes 30 seconds to uh, give the response. So that's a very high number. So if it's a 30 second, then I will put the draining interval like maybe 40 seconds. Okay. So what will happen basically in case of uh, the unhealthy instance, right? So I want to bring it down. So what NLB or any ALB would do is basically it will stop sending the new request. You will only the old requests which were actually getting processed before the instance became unhealthy. Only those would get processed. And what it will do, it will wait for 30-40 seconds after it is termed as unhealthy. Whatever time you mention in the unhealthy draining. This is basically associated with auto scaling group or elastic container service. And then what I mentioned is it is for deregistration management is here, which is called as deregistration delay. And traffic configuration, basically you want to make it work like in a proxy. So proxy is basically it will hide the details. So here we are saying preserve the client IP address and forward to traffic. Don't act like a proxy. That's what we are saying. And then there are some options of cross zone load balancing. Like you want to enable it or disable it, what we already discussed. So this is all available in the target group attributes. Just keep that in. Okay? Here you can set all those things. In case of say suppose if I create a new target group, say and group for ALB. Let's do that. And we have this port 8080, we have this VPC, and here I will put the health check path. And once I do that, I go do next. I use this instance. I have added this instance now. So I do next. We'll just create a target group. You will see some difference in the target group. Let's check that out. Now this is for the ALB. Let's check the target group attributes. Again, the deregistration management in ALB, which we spoke about for the in-flight request. Okay, the request which were already sent. How much time should we wait before we actually terminate the instance? Now, in case of ALB, you get this configuration of load balancing algorithm. It is not there in the NLB. NLB, it uses flow hash algorithm by default. Okay, so that's the difference. And in ALB, you have these three options of a round robin, least outstanding request, and weighted random. The round robin is basically it will just in the sequential order. First instance one, instance two, instance three, instance four, instance five, instance six. In that way, it will keep on sending the request. Then again, like it will start again from instance one, instance two, instance three, instance four, instance five, instance six. But in case of least outstanding request, it's basically it's going to see okay which instance is basically more free basically to take or is ready for more request, right? It has the load capacity. So it's basically with this least outstanding request. So that ALB will decide, okay, this particular instance has the bandwidth. Okay, I'll send to this. So it's basically we have very complex or different kind of processes that are there. Then you would go with least outstanding request. Weighted random, it's basically evenly. It's evenly across healthy targets. That's it. And then we have the stickiness option. Okay, stickiness option is the load balancer generated cookie. So in ALB, we have this AWS ALB, that cookie is generated. So we can basically bind a user session to a specific target. Okay. Suppose it is calling a particular instance EC1. Basically, that session has already started, right? I want to maintain that session between that client and the instance, right? So you can use this stickiness. And then that stickiness, you can have that duration also, right? For how long you want it. It could be seconds, minutes, hours, and days also. This is very useful as far as the gaming and all those stuff are concerned. So this was about the target group. So once you have created the target group, so what we did, just to recap, we created a VPC, we launched the instances, we created the target group. Now we create the load balancers. How do we create the load balancer? Is basically you choose this option, right? For NLB, you provide this load balancer name, whether it is internet facing. Basically, external clients can actually call or access this particular NLB or not. Whether it is dual stack or only IP version 4, you select the VPC. You select the security group as well. So what all protocol etc. are you allowing? And then there is a listener, right? You have this particular protocol TCP and then port 80, etc. 8080, whatever you want. So this is how you can create the network load balancer. I have already created it. We'll just walk through that. So I have used our VPC. There are two availability zones used here. And just keep one thing in mind, you need at least two availability zones. Okay, two subnets basically in two different availability zones for even for your ALB and even for this NLB. And then you get the DNS name once the uh, load balancer is created. And as far as listeners and rules are concerned, see, I have now two listeners here. One listener is listening on the uh, transport layer security. Basically, it's a secure connection. And the other one is the 8080. Is listening on the TCP 8080. It's just a simple rule that we have here. It is just going to forward to a target group here. In ALB, it's a way bit complex. We have options of like path based, query based, because it can read the headers, right? It can read whatever is being sent. NLB cannot read it. NLB cannot understand what is being sent. It just knows the client IP, source IP, source port, destination IP, destination port. That's it. So it cannot manipulate the header. That is why you cannot have any rules here. You just forward it to the particular instance. And for the secure socket layer, okay, for the TLS, what we are doing is basically we attach certificate. Okay, now this certificate is created in the ACM itself, basically AWS Certificate Manager. I have created a certificate for my domain. As you can see, this is my certificate, and I am just using that certificate. So it's a direct integration that we get in the NLB or ALB in both of them. Once this is done, so now my network load balancer is working fine. Now what I can do is I can directly call the network load balancer. It is working fine. Here I am providing 8080. I am using the network load balancer's DNS port number 8080, and then I am sending this. Okay, so it is working fine. It is able to send it to the target group. Now suppose how do I access the TLS or the secure connection, right? So for that, there is one more thing that I have done. We can use Route 53. In the Route 53, we go into our hosted zone. So this is my domain name, and in that domain name, I have created this record. So in this record, if you look here, so this is the basically my host, you could say host name or something, nlb.htvision.click, and then what it is doing, it is routing to another domain. So I'm using cname, which is to another service. Okay, another domain or to other service, we use cname, canonical name, and then I am here pasting the DNS of our ALB, and then this is time to live, and then that's it. We are ready. Now, instead of using this, what I'm going to do is going to open that it's working fine, and look here. See, this is HTTPS connection. Okay, now this is a secure connection. Here in the secure connection, it is using the certificate that I had created. Okay, through the AWS Certificate Manager, and that is where it is able to get the certificate and verify it, and then the secure connection was able to we are able to establish that connection. And also one more thing which happened here, which I spoke about, the SSL termination, right, or the TLS termination that happens between here. As you can see in this listener, I was listening on 443. Here it is by default 443 HTTPS, and then it used my certificate. Now this is my domain, right, htvision.click, and see, look at my host nlb.htvision.click. So this is my DNS, and then it was able to verify its certificate from AWS, and once it did that, then it forwarded to this particular target group. Okay, now if you look at this target group, you can see it is going to TCP 8080. So this is not a secure one or the secure connection. So here what it is doing, after it reaches here, after it validates everything, and then it will terminate the TLS connection, and then it will start the normal TCP connection. So that's called as TLS termination in this case, what we had seen in this diagram. Okay. So this is the demo for network load balancer. Thank you so much.